How did Roman aqueducts make water flow uphill? By using an inverted siphon, gravity created pressure, forcing water to ascend. While it's a myth that Romans defied gravity, they didn't make water flow uphill in the magical sense. Instead, they used sophisticated engineering to maintain a constant downward slope even when the terrain was uneven, and employed a clever physics trick called an Here is how they mastered the movement of water across vast distances. The secret to Roman aqueducts was not power, but gravity. Engineers calculated a steady slope that allowed water to flow naturally from a high mountain spring to a distant city. Usually, the drop was as little as 1 to 2 meters per kilometer. The corobodies and groma were used to ensure the aqueduct floor never tilted upward, preventing water from stagnating. When an aqueduct reached a valley too deep or wide to build a bridge across, engineers used an inverted siphon. From this tank, water was funneled into narrow lead pipes. These pipes ran down the valley, across a low bridge, and up the other side. Because the exit tank is lower, the water's weight creates pressure, pushing it up the pipe. This is hydrostatic pressure in action. The inverted siphon was a feat of high-risk engineering. The press enough to burst the lead pipes. Multiplied the pipes. Instead of one giant pipe, they used several smaller ones to distribute the load. Stone casing. They often encased the pipes in heavy stone blocks to prevent them from expanding and leaking. They built a low bridge across the center of the valley to reduce the total vertical drop, thereby lowering the peak pressure at the bottom. Most of the Roman water system was underground. Tunneling protected the water from evaporation, pollution, and enemies. When a hill stood in the way, they dug through it. They used vertical shafts called puttae for alignment and oxygen. Inverted siphons use gravity to move water across deep valleys. High pressure on one side drives the flow to the other. Settling tanks. To slow the water down and let sediment sink before reaching the city.